I will show you how to perform the conduction experiment in the ANSYS software. So let us take this value for the conduction. And next video I will post how to perform the convection analysis with help of fins. So here the thermal conductivity is 50 watts per meter Kelvin, and the plate is about 100 degrees Celsius on the left side and 20 degrees Celsius on right side, and the dimension is 12 mm. So let us assume some different dimension and we will solve the problem. How to solve this conduction, right? So first preference, in the preference we have to change the type of analysis, that is thermal analysis. And preprocessor, in the preprocessor we know that we have to enter the element which is suitable for the this analysis. So here solid element, because we are going to do a solid analysis. So here the four plane 55 which is suitable for doing a conduction analysis of a 2D element. So that is a quad 4 node 55. So just like okay, you will see that is plane 55. And material property, in the material property for analysis of a thermal we need only conductive. Suppose if you are doing uh, mm, structural analysis, means you will need to enter um, Young's modulus value and Poisson ratio. For vibration based problem, density is must, right? So here the value is 50 meter per 50 watts per meter Kelvin. So let us take a 50, then click OK, right? So here I am going to take uh, plate of 1000 mm, 1000 mm, 1000 into 1000. That means we have to convert that into meter. That means let us assume that is 100, right? So for a plate of 100, I am going to draw this plate of 100 with help of a modeling area and rectangle by dimension. So 0 and 100, 0, 100. So enter the 0, 100, that is called as a key point, right? Sorry, not a key point, that is called as a coordinate point, right? So what is the x distance from starting to ending? What is the y distance from starting to ending? So that is 100, 100. Now I'm doing meshing operation, that is called as a discretization by selecting the area. So that is simply we just enter the one as a element edge length and again raising the mesh tool and mesh the area. So now we will get a very fine mesh, right? Now apply the temperature. So applying the temperature on line, right? So in the solution you have an option, that is what is the analysis type, whether the steady state analysis or transient analysis or substructuring. So now we are doing steady state analysis, so just click OK and go to the load and apply and thermal and the temperature online. So this side, let us assume this two side the temperature will be 100 degree or plus 273, which is in the Kelvin, right? It also accepts the mathematical operator in the value column, right? And apply here this two side will be 50 degree. So why I am entering this Kelvin means because in the conductivity value we entered 50 watts per meter Kelvin. So I entered this value into Kelvin. So in the both side of a top and bottom plate, bottom side of the plate, I am entering 50 plus 273 Kelvin, right? So now we have to solve this problem and see the result. Just click the solve and click current LS. Solution is done. Okay, now we have to see the result by using the plot result, contour, nodal solution, and in the degree of freedom solution, click the nodal temperature. So this is what the result of conductivity analysis, right? So we applied the temperature on the left side, on the right side of the plate is 100 degree, that is 100 plus 273, 373. So that means the temperature is 373 Kelvin, and top and the bottom of the plate we applied 323 Kelvin, and you can see the flow of heat, that is distribution of temperature, is shown by the analysis. So now you can observe the various temperature ranges in the plate. So from that we can able to um, design, so based on the heat transfer, that is the temperature distribution for a required component, right? Thank you.